fMRI, the line of thoughts that most people sit in, including me, often is that of cognitive neuroscience. And here the agenda is to link psychology, so the science of the mind, and neuroscience, the science of the brain, the organs. And so really we're interested in describing complex behaviors like driving, for instance, which is a combination of understanding the scene and decision making and motor control. So we're interested in explaining this behavior based on their neural implementations. In machine learning, I define machine learning as computational statistics for prediction. Something quite important is I make no opposition between machine learning and statistics. Machine learning is a variant of statistics. It's completely fine. It's just focused on out-of-sample properties, and it has a lot of computational aspects to this. And what's driving in general in many sciences the use of machine learning is a paradigm shift, because the dimensionality and the complexity of the data is growing, and this enables richer models. And so with those richer models that we will be fitting with machine learning, then we can ask more open-ended questions. And those open-ended questions basically correspond to a larger set of features. But this is shifting the way we work from parameter inference and statistical control on parameters to prediction and statistical control on prediction. And so we need basically to rebuild our methods or scientific methods to use this. And the important thing is that cognitive neuroscience is most often focused on understanding, not predicting. Now, I'm becoming more and more easy with this, because understanding is a very ill-defined word, and quite often understanding just means finding things that we know and basically opening a model and finding things that we know. And these days, I believe that a prediction is a better model selection tool. I'll come back to this. Anyhow, a bit of a gap between just throwing machine learning in something and the goals of science that are to build a narrative that understands things. And so if we look at machine learning and imaging brain activity, we have on the one hand measurements of brain activity, and on the other hand, descriptions of behavior and pathology. And our general, goal or general thought is that we're going to be trying to learn associations between the brain and the mind that generalize. And so once we think about generalizing, we think about machine learning. So we're going to be using machine learning for this. And so for instance, if we're given brain images, we can try to predict behavior or pathology, and this can be a diagnosis problem if we're in pathology, but in general, it's really about interpreting these brain images, because most of the time, if you give me a brain image, it's actually quite challenging to interpret, and putting formal interpretation on brain images is basically going to lead us to machine learning-like problems. Now we can go the other way, and we can try to predict brain activity from behavior or pathology. Why is this interesting? Because it will enable us to decompose aspects of behavior that are important for the brain activity. And this is actually a non-trivial task. Behavior is an extremely rich quantity. Well, it's not a quantity. Quantifying behavior by itself is a challenge. So if we find quantifications of behavior that predict better brain activity, these are probably better quantifications of behavior. We can also be interested in analyzing brain activity by itself. For instance, when we have resting state, this is potentially useful, because then we don't need finely controlled and finely quantified behavior. And finally, we can also be interested in analyzing behavior by itself. And this is quite important, because if we need good representations of behavior, we might have more behavior that is available, more recordings of behavior or descriptions of behavior that are available without brain activity. So we can run, massive analysis of this behavior to find structure in it. So these are typically, all these things are problems that I can tackle with machine learning, supervised machine learning for here and here. So when we're predicting brain activity or we're predicting behavior, and unsupervised machine learning or semi-supervised or self-supervised when we're just looking at brain activity or just looking at behavior.